Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 11 to 15 of the Algebra 2 Semester 1 final exam. Let's take a look at question 11. It reads, solve the equation by using the quadratic formula. To get started, we're going to go ahead and write down what the formula is. The quadratic formula is as follows. So let's write that down. If we have a quadratic equation in standard form, then the solution will be given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So let's go ahead and write down the equation that we are solving using the quadratic formula. First things first, you want to ensure that your equation is in standard form. Every term is written in descending order of degrees and is set equal to 0. If it's not in standard form, you have to place it in standard form first. This will enable us to accurately determine the a, b, and c values. So this example is already in standard form, so we can proceed to determine what a, b, and c are. Okay, they are the coefficients of the second degree term, the first degree term, and the constant. So we have a is 2, b is 5, and c is negative 3. Alright, now we'll just simply substitute these values into the quadratic formula. That will yield x equals negative b, which is 5, plus or minus the square root of b squared, 5 squared, minus 4a is 2, and c is negative 3. 4ac divided by 2a. Okay, when you're dividing, make sure you divide the entire numerator expression by 2a. Now all we just have to do is use the order of operations to simplify this expression right here. So let's see what we have. Negative 5, let's simplify the radicand. Square root b squared is 25 minus 4 times 2 times 3. 4 times 2 is 8 times 3 is 24. Since we have negative and a negative, minus times minus is plus, plus 24. That divided by 2a, which is 4. 2 times 2 is 4. Alright, let's simplify further. We'll have negative 5 plus or minus the square root of 49 divided by 4. So we know what the square root of 49 is. Square root of 49 is 7. So we have negative 5 plus or minus 7 over 4. In this case, we have two equations in one. Two expressions in one. So we have to split it up into two. So we're going to have the negative part and the positive part. Okay, so let's do the negative first. Negative 5 minus 7 over 4. That's going to be the first solution. And then the second one is going to be negative 5 plus 7 divided by 4. Now let's simplify. On the left side, negative 5 minus 7, that's negative 12, divided by 4. Negative 12 divided by 4 is going to be negative 3. Negative 5 plus 7, we're going to subtract there. That gives us 2 over 4, which is 1/2. Just divide top and bottom by 2. So our solutions using the quadratic formula, our solutions are x equals 1/2 or x equals -3. Let's see what the answer is. The answer is option letter B. Let's take a look at question 12. In this problem, we are adding two complex numbers. Okay, so we have to add 3 plus minus 4i and 5 minus 6i. It's very good to add complex numbers vertically, okay? Even when you're subtracting, just orient it vertically so you can line up the real and imaginary parts of the complex numbers. Okay, so we have them lined up, the real and imaginary parts. The operation here is plus. 3 plus 5 is 8. Negative 4i plus negative 6i. Signs are the same. You add and keep the sign. Negative 10i. Answer is option letter C for number 12. Okay, let's move on to 13. We have to simplify the difference between these two complex numbers. So we have 1 minus 3i minus negative 3 plus 7i. Notice I oriented them vertically as I did in question 12 so that I can combine the real and imaginary parts vertically with ease. Now let's go ahead and carry out this distribution here. When you're subtracting, it's the same as adding the opposite. So I'll distribute this sign to all these two terms, the real and imaginary parts. So we have 1 minus 3i, that's unchanged, plus 3, minus times minus is a plus, and then minus times this plus right here is a minus, minus 7i. Now we can just combine both of them downwards to get our final result. 1 plus 3 is now plus because we're adding the opposite. 1 plus 3 is 4. Negative 3i minus 7i is 10. Answer for question 13 is option letter A. Now, number 14. We're to find the vertex of y equals x squared plus 2x minus 3 and state if it is a maximum or a minimum. Now there are two ways you can determine the vertex of this quadratic function. You can either use completing the square or you can use the formula. Alrighty, I'm going to use the formula here because it's very direct. We have y equals x squared plus 2x minus 3. The formula for the x coordinates, let's write it down. For the x coordinate of the vertex is negative b over 2a. The formula for the y coordinate of the vertex is the function evaluated at the x coordinate of the vertex, which is f of negative b over 2a. So all you simply do is take your x coordinate of the vertex that you got earlier and plug it into the x's in y, and that will help you determine what the y coordinate of the vertex is. Okay, so as you can see in the formulas, all we need to find the vertex are a and b. Actually, yes, a and b. So a is 1 and b is 2. So let's see. Let's start by determining what the x coordinate of the vertex is. So x vertex is equal to negative b over 2a, which is negative 2 divided by 2a. That gives us negative 2 over 2. If you divide this out, you end up with negative 1. Now with the x coordinate of the vertex, we can find the y coordinate of the vertex, right? Because the y coordinate of the vertex is a function evaluated at the x coordinate of the vertex. So we are evaluating f of negative 1. So what does this mean? This expression here, f of negative 1, simply means you're going to evaluate this function at x equals 1. Substitute 1 for all the x's. Let's go ahead and do it. If we carry out the substitution, we'll have negative 1 squared plus 2 times negative 1 minus 3. Using the order of operations, please excuse my dear Aunt Sally, we can simplify this. We have positive 1 minus 2 minus 3. That gives us 1 minus 5, which is equal to negative 4. So our vertex is negative 1, comma, negative 4. So we can eliminate options C and D. Our answer is either A or B. So is our vertex a maximum or a minimum? The sign of A will help us to determine the opening of our parabolic function. Okay? Remember, A is 1, right? So since A is equal to 1, a value that's greater than 0 or positive, this means that the parabola is going to be happy. Okay, it opens upwards. Visualize a smiling face. Okay, the parabola opens upwards. That right there is your vertex. So the vertex is that a low point or a high point? Is that a peak or a valley? This is a valley, right? So that basically is a low point, which tells us that the vertex is a minimum. Okay? So our vertex is negative 1, comma, negative 4, which happens at a minimum. Answer is option letter B. Alright, let's take a look at 15. It reads, the height of Carl, the human cannonball, is given by h of t equals negative 16t squared plus 56t plus 40, where h is in feet and t is in seconds after the launch. A part, what was his height at the launch? So let's figure that out. So the height at the launch is the height when t equals 0. Basically the time at the beginning. Okay? So height at the launch is the height when t equals 0, right at the start. So what are we going to do here? What we're simply going to do is evaluate this function when t equals 0. We are supposed to find out what h of 0 is. H of 0 is simply what you get when you substitute 0 for the t's in this quadratic function. Okay? So you have negative 16 times 0 squared, inputting 0 for the t, plus 56 times 0 plus 40. Okay? Simplifying this using the order of operations, we have 0 plus 0 plus 40. Final answer is 40 feet. Alright, next we're to find what the maximum height is. Okay, so for part B, the maximum height is basically the y-coordinate of the vertex. And as we discussed in the previous problem, the y-coordinate of the vertex is basically the function evaluated at the x-coordinate of the vertex. Okay, so all we have to do is find the x-coordinate of the vertex first, and then plug it into the original function, and that will tell us what the y-coordinate of the vertex is. So let me just illustrate what's happening here for you. Okay, so the human cannonball was launched upwards, and then he hits the maximum height and then comes falling back down until the person hits the net, the safety net. The safety net is somewhere down here. Okay, so this is the maximum height we're talking about. It occurs at the vertex. Okay, x vertex, y vertex. The x vertex is the time that it hits the maximum height. And the y vertex, which is the maximum height, is what we're looking for in this problem. So this is the h max that we're talking about. Alrighty? Okay, so let's go ahead and find the first part, x vertex, the time that it reaches its maximum height. X vertex is negative b over 2a. So let's call up the quadratic function. Negative 16t squared plus 56t plus 40. It's already in standard form, so we can easily see that a, coefficient of the second degree term, is negative 16, b is 56, and c is 40. Now let's find the x-coordinate of the vertex. It's going to be negative b over 2a. Okay. So we are going to have negative 56. 2 times 16 is 32. We can divide the top and the bottom by negative 8. That's a GCF. Divide by negative 8, top and bottom. Since they're both minuses, minus over minus is plus. So we can just slash and dash, and we will have 7 over 4 as our as the time when this quadratic function hits its maximum height. So we have 7 over 4. What's the unit of time here? Seconds. So 7 over 4 seconds after lunch, our human cannonball has attained its maximum height. But what is the maximum height? So now we'll just simply substitute this into the original function to find the y vertex. Okay? So y vertex is going to be negative 16 times 7 over 4 square plus 56 times 7 over 4 plus 40. So we're now going to just use the order of operations to simplify this resulting expression here. Okay? So what is 7 over 4 raised to the second power? 7 over 4 raised to the second power just involves squaring the numerator and the denominator. So that gives us negative 16 times 7 squared is 49. And don't forget the denominator. 4 squared is 16. Okay, plus 56 times 7 over 4 plus 40. Now if you take a look at the first product here, the 16s divide out, we're left with negative 49. And we can do some reduction here before we multiply. 4 goes here once, 4 goes into 56 14 times. And then when we multiply 14 times 7, that's the same thing as 70 plus 28, which is 98 plus 40. Okay, if you combine all these numbers together, you end up with 89 feet as your maximum height. Now let's take a look at the C part. It asks how long before he lands in the safety net 8 feet above the ground. So for the C part, we're going to find the time when he hits the height of 8 feet, which is basically where the safety net is. So the time before he hits the net at 8 feet just involves solving for we have to solve for is a time value t where the function has a value of 8. So we'll just simply set our function to 8 and then we'll solve. Okay, so let's go ahead and do that. We have negative 16t squared plus 56t plus 40. 56t plus 40, that is our function. We want to find a t value that makes it equal to 8. Now to solve this quadratic equation, first step is to put it in standard form. We have to set it equal to 0 with terms in descending order of degree. We have an 8 on the right, so we'll subtract the 8 from both sides, and then we'll have negative 16t squared plus 56t plus 40 minus 8 is 32 equals 0. Now when we are solving quadratic equations, if at all possible, it is beneficial to reduce the equation to its simplest form. So the question is there a greatest common factor that I can divide the entire equation by to reduce this equation to its simplest form? And the answer is yes. 8 is a common factor of 18, 56, and 32. That is the greatest common factor. So we're going to divide both sides of our equation by negative 8. And then we'll have the reduced quadratic 2t squared minus 7t minus 4 equals 0. Now I divided by negative because the a had a value of negative, okay? It had a sign of negative, that's why I divided by negative 8. Now to solve this, we're going to use the factoring method. Hopefully this works. If not, we'll have to resort to implementing the quadratic formula. We'll place AC on the top, B goes on the bottom. AC is negative 8, B is negative 7. And now let's play the X game. What two numbers multiply to give negative 8 and add to give negative 7? So we can do 1 and negative 8. If you multiply these two numbers, you get negative 8. And when you add them, you get negative 7. Now one thing to note in this problem is that a is not equal to 1. So what does this mean? We have to factor by grouping. There's no shortcut here. Okay, so let's go ahead and do that. We now rewrite this equation as 2t squared minus plus 1t minus 8t minus 4 equals 0. Now to factor by grouping, we'll divide it down the center. From the first two, we'll factor out the GCF, which is t. We'll be left with 2t plus 1. From the next two terms, we'll factor out the GCF, negative 2. Actually, we can go bigger. How about 4? 4 is the GCF of 8 and 4. Okay, and then we'll be left with 2t, take out a minus from here, plus 1 equals 0. Now these two quantities in the parentheses are identical. We'll go ahead and factor them out, and we'll be left with t minus 4. Set that equal to 0. Now we implement the zero product property to finish this problem off. Take both quantities and set to 0. So 2t plus 1 equals 0, and then t minus 4 equals 0. If we solve the first one, subtract 1 from both sides and divide by 2. We'll have t equals negative 1/2 seconds. And then for the second equation, just add 4 to both sides, and that leaves you with t equals 4 seconds. Now this answer makes no sense because time doesn't travel backwards. Okay, time cannot be negative, so eliminate this result, since time has to be greater than or equal to 0. Alright, so the answer that we're looking for is 4 seconds. Okay, so let's go ahead and just state what this answer means. The answer means that